saying, first of all, is to create a camera class. So what I can do is start with that. Creating a camera class, having a class here, camera, and having a constructor. And maybe here we could pass all the camera parameters, which are field of view, right? For example, here, field of view, we have eye, at, up. We can pass these guys, or we can actually, let's just pass field of view and aspect, a ratio, aspect, near, far. Sorry, far. These are the arguments of the projection. And wait, this, I can't see the questions. I cannot see Zoom at this point. Okay, more chat. Okay. And here, what I want to do is essentially, I want to bring all these matrices and stuff to that class. I want to encapsulate these ideas here inside inside that class. So for example, I want to start by moving this attributes, this guys here, and I want to say that this is a part of the camera. This is actually here. And the matrices themselves as well. I want to say view matrix and projection matrix. And whenever you render the world, essentially we're gonna have to update these values in the shader before rendering. But here, if you follow the documentation, you'll see that you should add here some functions to help you. For example, one is move forward. You can say move backwards. And then I can move left. Move right. And then you have pan left, pan left, and pan right. I think. Move forward, move left, pan left, and pan right. Okay, so these are the functions we ask you to implement. We note that we won't be grading you if you actually follow this structure or not. You don't even need to create a camera class if you don't think that's a good structure for your code. But we believe it is, and it makes it much more modular. But feel free to change these names and like even the arguments is not rigid. We won't grade you based if you actually matched exactly these definitions here. But if you're doing that, remember to load your camera here. And then we have this. And I'm going to pick another function here to update view, because this is a very long, remember, very long call, like this specific call here. What I want to do is I want to have it in here and just say like this.view camera, view matrix, this.eye, this.center, this.up, and so on. So for all of them, I want to do this, 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 this. Okay. Okay. Because then, and then whenever you want to update the view, we can just call this function, and it does. You don't have to call all these huge things again. Like you don't have to make this huge call all the time. So I think it's nice to compress it in this function. And with that, what we can do is now, I think all of this is in the camera. All of this is in the camera. This is not in the camera yet, so I'm going to keep it here. This is not in the camera also, but so let's move it there. I'm going to remove this. And I'm going to say here, I'm going to set the projection matrix right here. And this is going to be field of view, aspect. Let me copy this for now. Near and far. Okay. And here, what we have to do is just make a camera, which I'm going to make it global, a new camera, and the values are going to be these values, the same values that we had used before for field of view, aspect ratio, near and far. And I want to move these lines inside our render function. Because whenever you call render, we're going to update. We're going to update the view matrix and the projection matrix. So we can actually keep all these guys together here. So the model matrix, we have it per object, but the view and projection matrix is the same for all the shapes. So we can do this before outside the loop. View matrix, projection matrix, but now this comes from the camera, right? And we have a camera variable here. So let's make this global. Let camera equals to null. I'm going to make separated the GL. Okay. So at this point, camera is going to be set. And when you create the camera is going to have the matrices in there, view and projection matrices, with correct values. I think in the beginning here, I want to call also, like when we construct, I'm going to call update view once to make sure this is called. And let me put this together here. We could have update projection as well, but let's keep it this way for now. You can create it if you want. And I think now that's it, because when you're rendering, we're going to update this matrix, but now we have to do camera.view matrix, because we are reading the elements from the camera now. Camera view matrix.elements, camera.projection matrix.elements. And here, let's say for a comment, retrieve uniforms. Well, I think I might have forgotten something, but that's what I wanted. I think the code looks very, very nice actually. This way. Okay, let me refresh this and see. Oh wow, really? No errors? Nice. Let me change the camera to see what happens, if it actually is working or not. It is working. Cool. Perfect. So we are now actually past time, but the next step would be doing this, which is computing the forward vector. And here I'm just going to make comments here, but for example, this whole this whole part here is going to be here. So I'm just going to keep the pseudocode. It's pretty much written here already, but f is also a vector, so you're going to have to create the vector, right? You're going to have to say that f equals to new vector 3, right? Something like this. And then you're going to have to f set. You have this attribution variable. This, remember that you have the function, for example, f.set, which is this equal thing. Somehow you have to say like at minus I. Also, minus doesn't work, so I'm going to have to do at, I think, sub I, something like this. Remember, these subtractions and all these functions for vectors are implemented. You should have implemented them here. So you have all these functions for vector operations already. So make sure to use them, and that's what we want you to use here. Okay. So I'm going to stop here, because then now it's just following these comments, and for each of these functions, you're going to have one of these bullet points to implement. Okay, so move left would be here, and so on. Okay, any questions? Okay.